Hello everyone. I'm Dr. Madhura, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology. Today I'll be teaching a topic in vector calculus, that is divergence of a vector field. If vector f is equal to f1i plus f2j plus f3k is a continuously differentiable vector function, then divergence of vector f is given by divergence of vector f or div vector f denoted by del dot f is obtained by doing the dot product between the operator del and the vector function f. So doing the dot product of dou by dou xi plus dou by dou yj plus dou by dou zk dot product with f1i plus f2j plus f3k, we obtain dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, where f1, f2, f3 are functions of x, y, z, and clearly divergence of vector f is a scalar quantity. Since there are no components I, j, k, vector components I, j, k, it is a scalar quantity. Note that if divergence of vector f is equal to 0, then vector f is said to be solenoidal. Solenoidal. We'll do problems based on divergence concept today. First question. Given vector f is equal to x square yzi plus y square zxj plus z square xyk, find divergence of vector f at 1, 2, minus 1. At 1, 2, minus 1. Divergence of vector f is nothing but del dot f. Is nothing but del dot f. So let us perform the dot product between the operator del and the vector function f. So dou by dou xi plus dou by dou yj plus dou by dou zk dot product with the given function f, that is x square yzi plus y square zxj plus z square xyk. So performing the dot product between these two, recall the property that I dot I is 1, j dot j is 1, k dot k is 1. Rest all dot products are 0. So we need to perform dou by dou x of x square yz plus dou by dou y of y square zx plus dou by dou z of z square xy. Let us perform the partial differentiation with respect to x, y, and z. First term, with respect to x, differentiation of x square is 2x. Y and z are constants, so we write them as it is. Plus, with respect to y, differentiation of y square is 2y. Z and x are constants with respect to y, so we write them as it is. Last term is the partial differentiation of z square with respect to z. Z square differentiation is 2z. X and x into y are constants, so writing them as it is. The sum is 2xyz plus 2yzx plus 2zxy. So the sum is equal to 6xyz. Now we need to evaluate divergence of vector f at the point 1, 2, minus 1. So we substitute x is equal to 1, y is equal to 2, z is equal to minus 2 in the above answer that we obtained for divergence f. So substituting, we get the answer as minus 24. So this was a basic problem on how we find out divergence of a vector function. Next question. Find divergence of vector f in the following cases. Vector f is given as grad of x y cube z square. We need to find at the point 1, minus 1, 1. And the second sub question is vector f is equal to grad of x cube plus y cube plus z cube minus 3xyz. So let us consider one by one. So for the first question, it is given as vector f is equal to gradient of x y cube z square. So the bracket expression, that is x y cube z square, we will denote it by phi. So that we have the expression, given expression in the form vector f is equal to grad phi. Now we will find out vector f using the formula for grad phi. Grad phi is defined as, we'll recall it from the last classes. So grad phi is defined as dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Let us find out these partial derivatives of phi with respect to x, with respect to y, with respect to z. Phi is x y cube z square. So partial differentiation with respect to x, y cube z square is a constant. Writing as it is, differentiation of x is 1. So 1 into y cube z square is y cube z square. Writing down I as it is. Plus dou phi by dou y. So we need to differentiate phi partially with respect to y. With respect to y, x z square is a constant. So we write down x into z square as it is. Differentiation of y cube is 3y square. So we get 3xy square z square j cap. Last term, partial differentiation with respect to z. So with respect to z, xy cube is constant from the expression of phi. Xy cube is constant. Writing down xy cube as it is. Differentiation of z square is 2 into z. So we get 2xy cube z into k cap. Now, divergence of vector f is equal to del dot f. So we have obtained now the expression for vector f as vector f is equal to y cube z square I plus 3xy square z square j plus 2xy cube z k. This is our vector function by evaluating grad phi. Now we need to obtain divergence of vector f. Divergence of vector f is del dot f. Del is an operator given by dou by dou x I plus dou by dou y j plus dou by dou z k. Dot product with vector f. Vector f, just now we have obtained y cube z square I plus 3xy square z square j plus 2xy cube z k. Perform the dot product between these two vectors. Recall, I dot I is 1, j dot j is 1, k dot k is 1, rest all dot products are 0. So we are operating dou by dou x of y cube z square plus dou by dou y of 3xy square z square plus dou by dou z of 2xy cube z. That's how we get the next step. Now we need to do partial differentiation with respect to x of y cube z square. Y cube into z square is a constant when we are differentiating with respect to x. So differentiation of a constant is 0 plus with respect to y, 3x z square is a constant. So differentiation of y square is 2y. Multiplying, we get 6xyz square. Lastly, with respect to z, 2xy cube is a constant. Writing down as it is, differentiation of z partially with respect to z is 1. So we get 2xy cube. This is divergence of vector f in terms of xyz. Now we need to evaluate divergence of vector f at the given point. The given point is 1 comma minus 1 comma 1. So we will be substituting x is equal to 1, y is equal to minus 1, z is equal to 1 in the above expression, that is 6xyz square plus 2xy cube. In this, when we substitute x, y, z, we get the answer as minus 8. So required answer for divergence of vector f at the point 1 comma minus 1 comma 1 is minus 8. There was a second sub question. The question was vector f is equal to gradient of x cube plus y cube plus z cube minus 3xyz. It's a similar problem to the previous sub case. So we'll assume first the function phi as x cube plus y cube plus z cube minus 3xyz. So vector f is in the form grad phi. The entire expression is assumed as phi. So vector f is equal to grad phi. Using the definition of grad phi, that is dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk, we will obtain dou by dou x of substitution of phi plus dou by dou y of substitution of phi into j cap plus dou by dou z of substitution of phi into k cap. So now we need to differentiate the expression for phi partially with respect to x, with respect to y, and with respect to z. Let us perform that one by one. With respect to x, differentiation of x cube is 3x square. Y cube plus z cube is a constant when we differentiate partially with respect to x. So differentiation goes to 0 minus differentiation with respect to x. 3yz are constants. So differentiation of x is 1. So we remain minus 3x, 3yz as it is. Into I cap plus with respect to y we are differentiating. So x cube differentiation plus z cube differentiation is 0. It's constant with respect to y. Differentiation of y cube is 3y square minus 3 into xz is a constant with respect to y. So differentiation of y with respect to y partially is 1. So we have minus 3xz into j cap. The last term is partial differentiation with respect to z. With respect to z, x cube plus y cube is a constant. So differentiation goes to 0. Differentiation of z cube partially with respect to z is 3z square minus 3xy is a constant. Writing as it is, differentiation of z is 1 into k cap. So this is the expression that we obtain for vector f. So vector f is given by, after performing grad phi, vector f is 3x square minus 3yzi plus 3y square minus 3xzj plus 3z square minus 3xyk. Now we need to perform divergence of vector f, which is given by del dot f. Del is a vector differential operator, dou by dou xi plus dou by dou yj plus dou by dou zk. Dot product with the obtained f. The obtained vector f. Performing dot product, I dot I is 1, j dot j is 1, k dot k is 1. So we will get dou by dou x of 3x square minus 3yz plus dou by dou y of 3y square minus 3xz plus dou by dou z of 3z square minus 3xy. Let us perform partial differentiation with respect to x. 3x square differentiation is 6x. Differentiation of minus 3yz is constant. So differentiation of a constant is 0. Next, dou by dou y of 3y square is 6y. Differentiation of minus 3xz is 0 when we differentiate partially with respect to y. Next, dou by dou z of 3z square is 6z. Differentiation of minus 3xy partially with respect to z is 0. So we get 6x plus 6y plus 6z. 6 is common. So x plus y plus z. The required answer for the given function is divergence of vector f is equal to 6 times of x plus y plus z. Now next we will see a problem based on solenoidal. What is solenoidal? If we prove divergence of vector f is equal to 0, then the function f is said to be solenoidal function. Show that vector f is equal to xi plus yj divided by x square plus y square is solenoidal. We are supposed to prove it is solenoidal. So we need to prove divergence of vector f is equal to 0. Consider the given function f. We'll split it into separate for ith component, jth component and kth component. So first term, x divided by denominator. So x divided by x square plus y square into I. Second term, jth component, y divided by x square plus y square into j. There is no k component, so 0k. Now, divergence of vector f we have to find out and show that it is equal to 0. Divergence of vector f is divergence del dot f. Del is a vector operator, dou by dou xi plus dou by dou yj plus dou by dou z k. Dot product with the vector f that we obtained just now, written in the form of I, j, k. Performing the dot product, I dot I is 1, j dot j is 1, k dot k is 1. So we get dou by dou x of x divided by x square plus y square plus dou by dou y of y divided by x square plus y square. Dou by dou z of 0 is 0 itself. Let us perform partial differentiation with respect to x, applying the quotient rule. With respect to x divided by x square plus y square, applying the quotient rule, u by v rule. V into du minus u into dv, the whole divided by v square. That's a formula for quotient rule. So v is nothing but x square plus y square. Write down v as it is. Differentiation of u, that is x, with respect to x is 1. 1 minus numerator, that is u, write down as it is. Differentiation of v, denominator, partially with respect to x is 2x. X square differentiation is 2x. Differentiation of y square with respect to x partially is 0. So we have only 2x. Divided by denominator square, that is v square term in the denominator. So v is x square plus y square, the whole square. Similarly, we'll perform partial differentiation with respect to y. With respect to y, denominator, that is x square plus y square, into differentiation of numerator with respect to y is 1, y with respect to y is 1, minus numerator, write down as it is, that is y, into differentiation of denominator x square plus y square, partially with respect to y is 2y. Differentiation of x square is 0 with respect to y, plus 2y. Differentiation of y square is 2y. The whole divided by v square. V is x square plus y square. So v square will be x square plus y square, the whole square. Simplifying this, we get x square plus y square minus 2x square, which will lead to minus x square plus y square divided by denominator term as it is plus x square plus y square minus 2y square. So y square minus 2y square will lead to minus y square. So we get x square minus y square divided by denominator as it is. Since we observe a common denominator, x square plus y square the whole square, we write on taking the LCM. Numerator is minus x square plus y square plus x square minus y square. We observe that the positive sign and the negative sign are cancelling. Minus x square cancels with plus x square. Simultaneously, plus y square cancels with minus y square. So we obtain 0 divided by anything, that is x square plus y square whole square. Answer is 0. So thus we have divergence of vector f is equal to 0. This proves that the given vector function vector f is solenoidal. Given function vector f is solenoidal. Thank you.